Let's take up the question number 4 of this paper. If 2y equals cot inverse root 3 cos x plus sin x divided by cos x minus root 3 sin x whole square, the entire function, x is in the interval 0 to pi by 2, then we have to talk about dy by dx. Let's try this question. 2y, it is given to me, cot inverse. If I divide numerator and denominator by 2, I can see this is root 3 by 2 cos x plus half sin x in numerator, meaning I can read it as cos x cos pi by 6 plus sin x sin pi by 6. Similarly, in denominator, sin pi by 6 cos x minus cos pi by 6 sin x. So I can change this function as cos pi by 6 minus x divided by sin pi by 6 minus x. Now, entire function you need to put square. This is clear? So this is simply cot pi by 6 minus x. Let's go ahead for this question now. We have cot inverse cot pi by 6 minus x whole square. X is given to me in the interval 0 to pi by 2, meaning pi by 6 minus x, it will lie in the interval. Let's write down pi by 6 minus x. It belongs to, since x is in the interval 0 to pi by 2, meaning minus x is minus pi by 2 to 0. Adding pi by 6, you can write here simply it is in the interval minus pi by 3 to pi by 6. Now I need to break it into two segments. This is important to see, although there is a possibility, since we are talking about one answer correct, so you will be getting only one of the two possible options which would be coming from here. So let's write down, this will be equal to 7 pi by 6 minus x whole square if pi by 6 minus x is lying in the interval minus pi by 3 to 0, and on the other hand you will have pi by 6 minus x whole square if pi by 6 minus x is lying in the interval 0 to pi by 6. This point is clear? Okay. On differentiating this term, you will be getting simply 2 dy by dx is equal to twice of 7 pi by 6 minus x into minus 1, right? So you can write here twice of x minus 7 pi by 6 or twice of x minus pi by 6 for the same interval what you have mentioned above, right? Just cancel 2 to get dy by dx as x minus pi by 6 as my result. So from the given options, we can see x minus pi by 6 is one of the given one. So correct answer for this question is option number 2. So I'm sure this is clear. Let's move on to the next one, that is question number 5. A point on the straight line 3x plus 5y equals 15, which is equidistant from the coordinate axis, will lie only in. Let's understand, if you have the coordinate axis like this, x-axis and y-axis, correct? Now, when you put here y equals 0, x is 5, x equals 0, y is 3. So you can draw the line in this fashion, correct? Now, when you talk about a point which is equidistant, clearly you can see if the point will be taken here, so you will get the distance from x-axis and y-axis as same. Moving ahead, if you go to the fourth quadrant, it will never ever come in the similar fashion. But if you move in the second quadrant, you can see somewhere here again you can get similar situation. So chances are there it will lie in first quadrant as well as second quadrant. Second option, just solve it. How? If it is equidistant, meaning you are talking about the intersection of this line with x equals y line or x equals minus y line, meaning x minus y equals 0 or x plus y equals 0. Substitute it to get the points of intersection as well, or directly we can conclude that the correct answer is option number 4. So I'm sure this is clear. Let's move on to the next one, that is question number 6. integral sine 5x by 2 divided by sine x by 2 dx is equal to. Simple question, let's start it. Integral sine 5x by 2 divided by sine x by 2. Correct? Let's multiply and divide by 2 cos x by 2. Right? So what we get here? In numerator we have 2 sine a cos b, that is integral sine a plus b giving you sine 3x plus sine a minus b giving you sine 2x. Right? Denominator simply 2 sine x by 2 cos x by 2, which can be written as sine x. I'm sure this part is clear till now. Now, in numerator we can expand sine 3x in terms of sine x. We can also expand sine 2x. We can take sine x common, which will cancel sine x of denominator. So here we get integral 3 sine x minus 4 sine cube x plus 2 sine x cos x divided by sine x multiplied with dx. So this is the result. Take sine x common, cancel it and integrate. What we are going to get? We will be getting 3x minus, we have 4 sine square x. We need to change sine square x into double angle, right? So let's write down here 4 integral 1 minus cos 2x upon 2 dx plus, now we have 2 sine x cos x divided by sine x is cancelled, so that gives you 2 sine x plus constant of integration. Moving ahead, we can write here 3x, this 2 will be cancelled, so we will be left with 2 only. Let's write down 3x minus twice of x minus sine 2x upon 2 plus 2 sine x plus constant of integration. Simplifying further, we can write it simply x plus sine 2x plus 2 sine x plus c. Let's see from the given options. X plus 2 sine x plus sine 2x plus c, meaning option number 3 is the correct answer for this question. So let's mark it as the correct one. I'm sure this is also clear. Let's move on to the next one.